Imagine standing outside just after a heavy summer storm. The air is cool, carrying that fresh, earthy scent of wet soil. The dark, heavy clouds are beginning to part, and a single ray of late afternoon sunlight cuts through the remaining mist. You look up, and there it is. A magnificent, glowing arch of color, painted across the gray canvas of the sky. It looks so real, so solid, like a colossal bridge built by giants, stretching from one end of the earth to the other. As a child, you might have wondered if you could run to the place where it touches the ground and find something magical waiting for you. But as you walk toward it, something strange happens. It moves with you. No matter how fast you run or how far you travel, the bridge remains just out of reach. That is because the rainbow is not a physical object. It is not waiting for you in a specific forest or on top of a distant hill. It does not exist in a single location at all. In fact, if you were to close your eyes, that specific rainbow would cease to exist. It is a beautiful, fleeting illusion, a ghost made of light and water, created specifically for your eyes and yours alone. But how does a simple drop of water paint the sky? And why, out of all the shapes in the universe, does this light always bend into a perfect, sweeping curve? To understand the mystery of the rainbow, we must first look at the two ingredients that create it, sunlight and rain. We tend to think of sunlight as being clear, or perhaps a warm, pale yellow. But this is nature's greatest disguise. Sunlight is actually a crowded bus, packed with every color imaginable. When these colors travel together through the empty vacuum of space, they blend perfectly, appearing to us as pure white light. But this white light is hiding a secret. Inside it, red, orange, yellow, green, blue, indigo, and violet are all traveling at the exact same speed, locked in a tight embrace. They only reveal themselves when they hit an obstacle. And after a storm, the sky is filled with millions of tiny obstacles. Falling raindrops. Think of a single falling raindrop not as a flat drop, but as a tiny, spherical glass house. When a ray of white light hits the curved surface of this water droplet, something dramatic happens. The light slows down. Air is easy to travel through, but water is thick and dense. As the light enters the water, it gets bent, a process scientists call refraction. But here is the beautiful part. Not all colors bend at the same angle. Imagine a group of runners entering a muddy field. The stronger, heavier runners might push through with less trouble, while the lighter ones get knocked off course more easily. In the world of light, red light is the strong runner. It has a long, lazy wavelength, so it doesn't bend very much when it hits the water. Violet light, on the other hand, has a short, rapid wavelength. It gets easily disrupted and bends sharply. As soon as the white light enters the raindrop, the colors are forced to separate. The tightly packed bus of colors has just opened its doors, and everyone is stepping out at slightly different angles. But the journey inside the raindrop is not over. The separated colors travel through the water until they hit the back wall of the droplet. Here, the back of the raindrop acts like a tiny mirror. Instead of passing straight through and exiting the other side, the light bounces off the back wall and heads back toward the front of the drop. As the light exits the droplet and steps back into the air, it speeds up and bends one final time. By the time it leaves the water drop, the colors are completely separated, fanning out into a beautiful, orderly parade of red, orange, yellow, green, blue, and violet. This process happens inside a single raindrop in a fraction of a millisecond. Now multiply that by millions. After a rainstorm, the air is filled with billions of these tiny, spherical mirrors, each one receiving white light, splitting it apart, and bouncing it back toward your eyes. But this brings us to the ultimate question. If millions of raindrops are scattering colors everywhere, why don't they just create a chaotic, messy smudge of color across the sky? Why do we see a neat, perfect, glowing arch? The answer lies in a magic number, 42. To see a rainbow, the sun must be behind you, and the rain must be in front of you. When you look at a raindrop, the light that bounces back to your eyes does so at a very specific angle. For you to see the red light, the angle between the sun's rays, the raindrop, and your eyes must be exactly 42 degrees. If the angle is even slightly different, the red light will miss your eyes completely, shooting over your head or landing at your feet. For you to see the violet light, the angle must be exactly 40 degrees. This strict geometry is what creates the shape of the bow. Imagine holding a long stick that is anchored to the ground directly where your shadow's head is. If you swing that stick around your head, keeping it at a strict 42-degree angle, the tip of the stick will trace a perfect circle in the air. Every single raindrop that lies on that circle is at the exact right angle to bounce red light directly into your eyes. Any raindrop inside or outside of that circle will send its light somewhere else. So the rainbow is actually a giant circle of light, centered directly on the shadow of your own head. But if it is a circle, why do we only see an arch? We only see a half circle because the flat ground gets in the way. The Earth blocks our view of the bottom half of the circle. There are no raindrops below the horizon to bounce the light back to us. However, if you were to rise above the Earth, perhaps flying in an airplane high above the clouds, or standing on the peak of a very tall mountain, the ground would no longer block your view. If you look down into the mist below, you would see something truly breathtaking. A complete, unbroken, 360-degree circle of glowing color floating in the air. A wheel of light with the shadow of your plane right in the center. This leads us to a mind-blowing truth about how we experience the world. Because a rainbow is entirely dependent on the specific angle between the sun, the raindrops, and your eyes, no two people can ever see the exact same rainbow. If you are standing next to a friend, looking at the same beautiful arch in the sky, you might think you are sharing the exact same experience, but you aren't. Because your friend is standing a few feet to your left, their eyes are receiving light from an entirely different set of raindrops than yours. Your friend is seeing their own personal rainbow, centered on their shadow, while you are seeing yours. Even your own two eyes are seeing slightly different rainbows, which your brain seamlessly merges into one. In a very real sense, the rainbow is a cooperative event between the universe and your consciousness. The sun provides the light, the storm provides the water, but it is your eyes that assemble the colors into a bridge. Without you there to catch those specific rays of light at that perfect 42-degree angle, the rainbow simply does not exist. It is easy to look at the world and feel that science takes away the magic. We are told that the glowing bridge in the sky is not a pathway to another world, but merely a trick of geometry, a calculation of angles, and the slowing down of light in water. But does that really make it less beautiful? The next time you see a rainbow stretching across the horizon after a storm, do not just look at the colors. Realize what is actually happening in that quiet moment. Millions of tiny droplets of water are falling through the air, acting as microscopic mirrors. The light of a star, 93 million miles away, is traveling through the cold dark of space, crashing into these tiny drops and bending at a perfect, sacred angle, just to meet your gaze. The rainbow is a reminder that even in the aftermath of a dark and chaotic storm, there is a hidden order waiting to be revealed. It is a quiet dialogue between the cosmos, the earth, and you. You are not just a spectator looking at a beautiful world. You are the very reason the sky is painting itself in color.